Today we'll be working on lesson 314, the quadratic formula. So before we start, I would like to review what the quadratic formula is. So x is equal negative b plus or minus square root of b squared minus 4ac over 2a. Now remember, this is a long formula, so for us to be successful, we need to first of all find the discriminant, which is b squared minus 4ac, first, and then apply it to or plug it in your formula. So let's start by doing the first example, which is 10x to the second power plus 11x minus 6. Now the first thing that you need to check for is this in the standard form? Since a, b, and c are all on one side of the equation, then yes, it is in standard form. So what you need to do next is try to find the discriminant and simplify it. So as you can see, a is 10, b is 11, and c is negative 6. So go ahead, plug it in. Minus 4a times c. Now remember, you need to find the discriminant first, and if it's b to the power 2, it means you have to put b inside the parentheses always. Now if you plug this in your calculator or you try to do it on your own, you're going to get that the discriminant is 361, which is a positive number, so I know that I have two real roots. Can I square root 361? Will it give me a perfect whole number? And that's the answer is yes, so plus or minus 19. So it's not only real, I also know that it's going to be a rational number. So the square root of 361 is going to be plus or minus square root of 19. Now, the new part in this lesson is to try to use the discriminant to find the solution for my equation. So what you need to do is you need to take your quadratic formula and write the adding root on one side and the subtracting root on the other. Now subtracting root does not mean that I will end up with a negative answer. It only means that I need to take the subtraction part of my formula. And remember, it's plus or minus, so the adding root is going to be the one with the plus and subtracting root will be the one with the minus. So let's go back and see what b is. As you can see, b was 11, so I'm going to have x equals negative 11 plus. I just found the square root of b squared minus 4ac. I got plus 19 and negative 19. I'm going to put plus 19 in the adding root over 2 times a. So a is 10. 2 times 10 is going to be 20. So x is equal negative 11 plus 19 over 20. X is equal to 8 over 20. If you simplify that, you're going to get 2 over 5. So x is equal to 2/5. That's going to be my first root. Now as for the other part, it's going to be exactly the same one, but instead of plus 19, I'm going to have a minus 19 over 20. So I'm going to end up with negative 30 over 20. You can simplify that and you will end up with negative 3 over 2, and that's your second root. And I already know from the beginning that I will have two real and rational roots, and that's what I got. Rational means there is no radical in your answer. So let's move on to our second example. Now remember, your first step is always to change it to standard form. So add 13 to both sides. So what you're going to get is x squared minus 4x plus 13 is equal to 0. Darkly decide what your a is, what your b is, and what your c is to be able to plug it in your discriminant and find that. So b squared is going to be negative 4, all of it to the power 2. See how I'm putting it inside the parentheses? Minus 4 times the a times the c. And that's going to give me, as you can see, a negative number. So my b squared minus 4ac is going to be minus or negative 36. Since it's a negative number, I know that I will have two imaginary solutions. It means my answer will have an I in it. So my second step is to simplify the radical. Since I have a negative under the radical, I'm going to put I square root of 36. Square root of 36 is positive or negative 6i. So it means I have either 6i or negative 6i for the part where the discriminant is. So in my adding root, I'm going to put x equals negative b plus whatever I got, which is the 6i, over 2a. And the subtracting root, I'm going to have negative b minus 6i over 2a. So negative b will be, as you can see, b is negative 4. So there's where you have to be very careful. So in the formula, you have a negative b, and the b in this case is negative 4. So you have to be careful is that this negative is part of the formula. You write it down. And b, always put it inside the parentheses. Plus 6i over 2a. In this case, a was 1. So 2 times 1. Now my x is going to be 4, positive 4, plus 6i over 2. Now, this could be your final answer, but if you look closer, you can see that you can simplify this since all of them are divisible by 2. So if you divide every single one of them by 2, you're going to get 2 plus 3i over 1, or you can just say 2 plus 3i. Now, since this is imaginary, you can directly know that your second solution is going to be the same exact one, but instead of 2 plus 3i, you're going to get 2 minus 3i. Or you can just plug everything like we did in the subtracting root, but you're going to get 2 minus 3i. Now let's move on. As you can see, we got 2 imaginary numbers since the discriminant was negative. Now let's move on to the third example. Now again, I need to put this in the standard form. So 2x squared plus 4x minus 5 equals to 0. Now you need to decide what your a is, what your b is, and what your c is. And you need to find b squared minus 4ac. Now b squared is going to be 4 to the power 2 minus 4 times the a times the b. And that will give you 56. Now as you can see, it's positive, so you have 2 real roots. But to decide whether they are rational or irrational, let's try to simplify the radical. Square root of 56 will give you a decimal, so it's not a perfect square. So that is an irrational root. Now to do this and to have more practice on simplifying radicals, I prefer if you go back to lesson 312 and review that. But remember, every time you want to simplify a radical, you try to think of the prime factorization or the factor tree. What multiplies to give you 56? 7 and 8. 7 is a prime, so circle that. 8, you need 4 and 2. 2 is a prime, so circle that. 4, you get 2 and 2, so circle these. Remember, every time you have a couple of a number and you have a couple of the 2, it means the 2 will go out of the radical. However, 7 is a single and 2 is a single. This 2 is a single, so the 7 and the 2 will stay inside the radical. So if you have a couple of the 2, only 2 goes out. This 7 is solo and this 2 is solo, so they stay inside the radical. So inside the radical you have 7 and 2, so that's going to be 14 inside the radical. So whenever you simplify the radical, you get plus or minus 2 square root of 14. Don't forget the plus or minus. Now to do the adding root, it's x equals negative b plus what you just found over 2a, and x equals negative b minus what you just found over 2a. So let's go back and see what b and a were. So b is 4 and a is 2. So x is equal negative 4 plus 2 square root of 14 over 2 times 2, since a was 2. Let me double check. Yeah. So the final answer is going to be x equals negative 4 plus 2 square root of 14 over 2 times 2, which is a 4. Now remember, if you have a square root and try to put it in the calculator, it will give you a decimal, but you don't want a decimal to be your final answer. But as you can see, all of these are even numbers, so you can simplify by 2. So if you simplify them by 2, you're going to get negative 2 plus square root of 14 over 2, since you divide every single one of them by 2. Now remember, do not touch what's inside the radical. It stays to be square root of 14. Now since this is an irrational function, and I know one of them, I directly know that the other one is going to be exactly the same one, but instead of plus square root of 14, it's going to be negative square root of 14. So this would be my 2 answers. So you can simply write it as x equals negative 2 plus or minus square root of 14 over 2. Now let's move on. Now in this example, again, you need to change it to the standard form. So I'm going to get x squared plus 2x plus 36 is equal to 0. Find your a, your b, and your c. A is 1, b is 12, and c is 36. The discriminant is b squared minus 4ac. So 12 to the power 2 minus 4 times 1 times 36. And if you find that, you're going to get the discriminant is equal to 0. Now what does that mean? It means I have only one real and rational solution. Why rational? We're going to see why in a minute. Now, remember, simplify the radical means you need to find the square root of 0. Now, the square root of 0 is just 0. Now, if we want to move to the adding and subtracting root, the first one is going to be x is equal to negative b plus square root of 0 over 2a. But it doesn't matter whether you're going to put plus or minus, because 0 is just, the square root of 0 is just 0. So this part of your quadratic formula is gone. So you are left with negative b over 2a. Because as you can see, plus or minus of square root of 0 is just 0. Okay, so it cancels out. Now let's go back to see what our b was 12 and a was 1. So x is equal negative 12 over 2 times 1, which is a. So x is equal to negative 2 over 2, which is negative 6. As you can see, we only have one real and rational solution because there's no radical. The radical is gone. So remember, every time you have a square root of 0, then this part of your quadratic formula is gone. And it does make sense, because if you look at it, you have only one solution, it means that this is how your parabola looks like. Right? So the vertex in this case is your root. You see that? So the x of the vertex, which is negative b over 2a, is going to be your solution. So now if you need more practice, please check our website for practice sheets and answer keys.